Hey guys, Miss Blake here. Today we're going to do part 1 of quadratic equations, which is section 1.5 in your book, and then I'll have part 2 video coming soon. So, definition of a quadratic, it's a second degree polynomial, so that's where that x squared comes into play. And in the general form, we have ax squared plus bx plus c. So remember a, B, and C are coefficients. There's different ways to solve quadratics. So today we're going to go over the first 2 ways, and then the second part of the video, the part 2, we'll go over the other ways. So the first one is by factoring, which is why you had that lovely factoring worksheet. So it looks like here we're going to pull out a GCF, 3x. If you divide out 3x, you're left with x minus 3. And we're going to use that zero product property, right? 3x can equal 0, and x minus 3 can equal 0. So x equals 0 is one of our answers. And add 3 to both sides, x equals 3 is one of our answers. Now here, remember, you always want it to equal 0, so we're going to subtract that 1 from both sides. And we're going to factor, so we want it to multiply to get 2 times negative 1. We want it to multiply to negative 2, and we want it to add to 1. So what multiplies to negative 2 and adds to 1? We got 2 and 1, and we want it to be a negative 1. So 2 times negative 1 is negative 2, and 2 plus negative 1 is 1. Up top you put your 2x. Why did my negative disappear? Alright, and then simplify. So these are both divisible by 2, so we get a 1. X plus 1 is one of our factors. And this doesn't simplify, so we're going to leave it. 2x minus 1 is our other factor. Still equal to 0. And then remember your 2 solutions. X plus 1 can equal 0, so x equals negative 1. There's one solution. And then 2x minus 1 can equal 0. Add 1, divide by 2, x equals 1/2 is the other solution. All right, moving on. You could also use a square root property, which is basically just square rooting both sides. So if you look here, I see that these are both divisible by 3, so I'm going to go ahead and divide by 3. And if I get this x squared alone, I can just square root both sides. So if I add 7, take the square root of both sides, remember you're going to wind up, oops, let me get the eraser. Remember, you're going to wind up with the 2 answers, positive and negative square root of 7. So just take the square root of both sides. Next one, I see everything's divisible by 5, so I'm going to go ahead and divide that GCF. I'm going to get that x squared alone, so subtract 9, and take the square root. Oops. Guess I'm going to be using this eraser a lot. There we go. The square root of negative 9. Now we don't want to leave that. Oops, sorry, plus or minus. We don't want to leave that, so we have plus or minus. Square root of negative 1 is I. Square root of 9 is 3. So square root of 9 is 3. Square root of negative 1 is I. So we have positive 3i and negative 3i. And the last one over here, again, I already see a squared, so I'm going to go ahead and square root both sides. Plus or minus the square root of 11. To get x alone, subtract 5. So here you have a minus 5. And you still have that plus or minus the square root of 11. Now if you put plus or minus square root of 11 and then minus 5. It's not necessarily wrong, but you want to put that minus 5 up front so there's no confusion over what's underneath the square root and what's not. So you'll always see that number out in front of the root. All right, so that's the square root property, that's factoring. That's your first attempt whenever you're trying to solve, is try to solve by factoring. Try that square root property. Those are going to be the easiest routes. Sometimes those don't work. There's also completing the square. So your little formula for completing the square is b over 2 squared. B divided by 2 squared. So completing the square means you're going to make a perfect square. You're going to make a perfect square. So we want something like this x plus 5 squared, so we can just square root both sides. All right, we're going to make that happen. How do you make it happen? There's your formula. So here a is 1, b is 6. So when you're trying to find out what you need to add, you're going to say b over 2 and squared. So 6 divided by 2 is 3, squared is 9. So we need to add 9. So when it says to write the trinomial, we're going to have x squared plus 6x plus 9 if we want to make that a perfect square. And the perfect square is going to be x plus 3 squared. Because x plus 3 times x plus 3 is x squared plus 6x plus 9. Over here, same formula. Negative 5 divided by 2 squared. Now the negative is not really going to matter because once we square it, it goes away. So we have 25 over 4. So what do we need to add to this? We need to add that 25 over 4. And then you'll get your perfect square. X minus 5 halves squared. All right, and then last one. So remember, dividing by 2 is the same as multiplying by a half, so we have 2/3. I'm going to say times a half, a little bit easier to see. That's b divided by 2 squared. Those cancel, so we'll have 1/3 squared, and we'll get that 1/9. So we'll have x squared plus 2/3 x plus 1/9. That will be my perfect square. X plus 1/3 squared. And now the last couple of examples that we're going to go over are actually going to be using completing the square. So let's go to our last two. So here I don't like this -1 because I can't factor this. You know, the only things that multiply to 1 are 1 times 1, and those are not going to add to 4, no matter which way you do it. So I can't factor this. So then I try completing the square. Let's get that 1 over. Since we don't like it, we want to make it pretty so we can complete that square. So we're going to add it to this side. Now remember, you want to add something to both sides to make it a nice, perfect square. But you have to add it to both sides so that you didn't change your equation. And that was the b divided by 2 squared. So 4 divided by 2 is 2, and squared is 4. So we want to add 4 again to both sides of your equation. You can't just add it to one. Now here, the reason I did it is because this will be x plus 2 squared. Right? 2 times 2 is 4, 2 plus 2 is 4. Over here we've got 4 plus 1 is 5. And now I have a nice perfect square, so I can take the square root of both sides. Square root of this side is plus or minus square root of 5. And then subtract the 2. Again, I'm going to put it up front, so we're subtracting. It's a -2 plus or minus square root of 5. And last but not least, notice here the coefficient of your x squared, your a term, is bigger than 1. We want it to be 1. So my first step, I'm going to go through and divide everything by 2. So I'm going to have x squared plus 3/2 x minus 2 equals 0. And again, not looking too pretty. So I'm going to add that 2 to both sides. I'll leave a little space here. So remember, for completing the square, we want to add something to both sides to make it a nice, pretty, perfect square. What do we add? It's that b divided by 2 squared. So 3/2 divided by 2 is the same as multiplied by 1/2 squared. So we have 3/4 squared, which is 9/16. So I want to add 9/16 to both sides. Looks pretty terrible here right now. All right, so we're going to go ahead and factor this. So that is x plus 3/4 squared. All right, that's why we did it. Equals. Now here, to combine like terms, you need a common denominator. So 2 is technically 2/1. I like the denominator of 16. Sorry about that. So we're going to multiply top and bottom by 16, so you get 32/16. All right, that's 2. Plus 9/16. Now we can add. So I'm going to leave this alone for now. Take a square root in a minute. So we got 9 plus 32 is 41/16. And now again, you have that nice perfect square, so we can take the square root of both sides. So take the square root of this side. We're left with x plus 3/4. Take the square root of this side. We're left with plus or minus square root 41/16. Running out of room a little bit, so we're going to bring this way. All right, so we're going to subtract 3/4 from both sides. So I've got x equals -3/4 plus or minus the square root of 41/16. Now we don't want to leave it like this, right? We know that we can split this, and we know the square root of 16. So we're going to go ahead and write -3/4 plus or minus square root of 41. I don't know that, but I do know the square root of 16 is 4. And see that lovely common denominator? We can actually merge this into 1. -3 plus or minus the square root of 41, all of that over 4. Nice, pretty answer. All right, that's it for part 1. We'll get to part 2 later.